Hey guys, how's it going? Last week we kind of introduced our new unit on inverse functions, and we had just a little assignment on solving algebraically for the inverse functions. And we introduced what it means to be an inverse, but we're going to dive a little bit deeper. And I'm also going to try and clear up some questions that came up from that first video to prepare you better for the clever assignment. So let's see what you learned from last week. So we talked about, in terms of a table, how we can find the inverse. So I want you to pause your video and see if you can fill in this second table if we're taking the inverse of the first table. Okay, so go ahead and try that. And magic, my table's filled in. So I want you to check your table with my table and see how you did. Remember that by taking the inverse, all we're doing is switching the x and y coordinates. So if we have -2, 3 in this first table, my second table will need a coordinate that's 3, -2, and we find that here. Now they're out of order to try and really test your knowledge. And hint, hint, you might see that in the future somewhere. So make sure that you know what you're doing there, okay? All right. Well, we also talked about how we can find the equation of an inverse by switching the variables. So if we are given this function of the quantity x - 2 squared - 7, what is the inverse function? Again, I want you to pause your video and try your hand at this. Okay, let's see how you did. I got the inverse of f is the square root of x + 7 + 2. How do we do? Remember, to find this, we're just going to switch our x's and y's and then solve. So for example, if I were to be setting this up, I would set my x here is equal to y - 2, excuse the chicken scratch, -7, and then solve for y. So I'll end up adding 7 to both sides, taking the square root, and then adding 2. Now, here's the thing. When you are doing this in Clever in your assignment, it wants it written differently, unfortunately, which is a little confusing. I like this notation. It shows the inverse of x, and it shows what x is. What Clever wants you to do is say that x is equal to the square root of y + 7 + 2. Essentially, what they are doing in the above is just solving for x. It'll get you your same answer, it's just a different notation. So I want you all to hear that, so when you get to Clever, I don't get a million emails saying, I'm getting the right answer, but I don't know how to put it in. There you go. Okay? Well, then there's also this cool thing that they ask, and they say, now find the input when the output is -3. So let's talk about these words. Normally, our input is x and output is y, right? We've got a function, we put in x, we put in a variable for x, and we get this output of y. But we switched that. So now essentially our output is x and our input is y, okay? And that's what we're trying to find. So we can do this one of two ways because we have our normal function and we have our new function, our inverse. So I'm going to first use my inverse, okay? So I'm first going to use the inverse function, whoa, if I can actually write this, and I'm going to solve. And I'm going to solve for, I'm putting -3 in because -3 is my output, right? So it's -3 plus 7 + 2. All right, well, that is the square root of 4 + 2. Square root of 4 is 2, but remember it's plus or minus and then +2. So we actually have two answers here. We're going to have 0 and we're going to have a +4. Okay? So remember, our output is x and our input is y this time. So in my normal function, I can also plug in numbers. So that's the second way I can do this. The second way I can do this is put in -3 and then solve. I can say that -3 is my y and solve for x. So -3 is equal to x - 2 squared, what was it, +7 - 7. Okay, and now we're going to solve for x, add 7 to both sides, x - 2 squared. Take the square root, same idea, we're going to have plus or minus 2 is going to equal x - 2. Add 2 to both sides, If it's a negative 2 plus 2 would be 0. If it's a positive 2, I would get 4. Okay, and I forgot to write that this was our y, right? So yes, we have two different variables, but because it's the inverse, it's actually going to be the exact same thing. So there's two ways. You can start with your original function, or you can start with your inverse function, so long as you can keep straight what your input and output are. Okay? Drop me a note on the side if you have any questions on that, because I know those words can be a little confusing. Okay, looking at our graphs now, we can apply this same principle of kind of switching our coordinates, right? So, for example, on this graph, let's pick a few good coordinates. Let's say this one's a good one, right? -2, -3. So if I switch that now, -3, and what was that, -2? So now my point is right there. That's a point. Okay, let's do another good point, maybe right here, 0, 0. That's still going to be 0, 0. Okay, let's do another one. This is a good point, 3, 1. So I'm going to switch that and have 1, 3. So I'm way out here now. Oh gosh, that looked like a smiley face, so I'm going to leave it. Lastly, this point, our ending point, is 1, 2, 3, 4.5, up 1, 2, 3, 4.5, 5? Yeah, 5. So my next point now is going to be 5 up 4.5. So I end right here, okay? So my graph, and my graph, if I draw it, is going to be terrible. So I'm going to show you mine, is going to look a little bit like this, okay? What I want you to notice is that there's almost like a symmetrical line here, a line of symmetry, if you will, right? So if I reflected this point over that line, I land, whoops, on that little blue dot right there, which is exactly what we calculated in the red. This one just looks a whole lot better, okay? Good, so this is what the inverse function looks like in purple, and our normal function looked like that in blue. So we can graph those two by just switching the coordinates, okay? We can also discuss the domain of these graphs. So let's look at another graph. Okay, these are the graphs that we just discussed, right? You found the inverse function from this graph, or from this function. I keep trying to pull these things away. So let's look at them, right? So if this is our original graph, okay, it's a parabola, it's quadratic. We want to talk about domain and what x values these graphs will cover. So if we remember what domain is all of the x values. So if this parabola kept going on forever and ever and ever, our x values would actually cover all of the numbers, so our domain is all real numbers. Well, what about the inverse? If I were to graph this inverse, I get something that looks like this, okay? This blue line is the inverse, and the red line was our original function. Notice that our domain now is not all real numbers, okay? Again, domain is all of the x values, okay? So notice that our domain, it's almost like it starts here and then it moves forward. Well, why is that? Let's go back to our graph here, okay? So our graph here, let's look at a few points. I can actually click on this. Let's look at a few points here. If I look down at this bottom point, that's 2, maybe -7. Let's look at a few more. Let's just pick some points. Maybe here is like 4.5, 0. Sure. Let's find another good point. Oh, this is a good point. This, excuse me, 0, -3. Okay, so now in blue, I'm going to write the inverse points. So we're just going to switch them, 0, 4.5, -7, 2, -3, 0. Right now, our lowest x value, right, if you think of our horizontal line, of our inverse function is a -7. Will there be something that is lower than -7? Could there be a -8? If you look on this graph, do we hit -8 on the y coordinate? We don't. So -7 is going to be our barrier. So now moving to my inverse, okay? My domain is going to be everything greater than -7. So we can write this in two ways. We can say that x is going to be greater than -7, excuse me. Or we can write this in interval notation saying that -7 is going to go towards infinity, okay? Now my original domain is going to be all real numbers, and you can just write that as all real numbers if it asks you, okay? All right, so let's check your understanding on that. I want you to think about what would be the greatest possible domain that would allow this graph to have an inverse. So think of the inverse of this function, just graphically, and think about what that domain might look like. So take a minute, maybe jot some things down and see what you think the domain might be. Okay, so now that you've thought of a few things, I'm again going to pull out some of these points. This first point we have is -3, -1. This bottom point is -1, -5. Again, we've got maybe 3, -5, and 1, -1. Whoa. All right, so if I switch these points now to find the inverse, it's going to be -1, -3, -5, -1, -5, +3, and -1, 1. So what is my lowest x value that I could have on my inverse? I've got -1, -5, -5, -1. Turns out that -5 would be one of those barriers. So my domain is going to start at -5. Is it going to go all the way to infinity? Let's look at the y values now. Or sorry, if we think of our x values, right? We have -5, we have -1. Could I have a 0? That would mean that I would need a y value of 0 in my original function. Here's my original function. Is there a y value of 0? There's not. So I have to stop at -1. This is my domain. Anything in between -5 and -1 will give me an inverse. Okay? All right, so there are definitely some questions on domain on your Clever assignment as well. Easy peasy lemon squeezy? I sure hope so. So I want you to show me that it is. Log on to Clever and complete the assignment from lesson 1 and 2. It's technically 4.6 in your book. We're going to do some jumping around here in this unit. So if you need more resources, you can check out 4.6 in your book. Then you can watch lesson 3 in Edpuzzle and complete that Clever assignment as well. You got this. We're in the home stretch. Let me know if you have any questions. Bye, y'all.